Okay, so in the last video, we saw an example of how to balance redox reactions in acid solution. What I want to do with this one is show you how to balance redox reactions if you have a basic solution. So now basic solution means you have OH minuses as well as waters around. And so that's what we're going to use to balance out these reactions. It's a little more complicated than acid solution, so just make sure you catch this and pay attention. All right, so once again, I'm going to do both methods. I'm going to do the half reaction method and the oxidation number method. So oxidation number method first. So I've got Mn2 plus. Obviously, the oxidation number for that is going to be +2. We go through the next one. Sodium, being an alkali metal, is going to be +1. Oxygen is going to be -2. So we have a total of -6. +1 means Bi needs to be +5. Moving to the product side, Bi is already noted as +3. In permanganate, oxygen is -2. There's 8 of them with an overall charge of -1, so Mn must be +7. So once again, I'm going to kind of connect the two things that are undergoing oxidation and reduction. And first thing I'm going to do is count how the electrons are changing. So I'm going from +2 to +7 here. So I'm losing 5 electrons in manganese. In bismuth, I'm going from +5 to +3. So I'm gaining 2 electrons in bismuth. So now that I have that taken care of, I want to make sure that I get the equations, I get the electrons balanced. So I'm going to have to multiply this guy by 2 and this guy by 5 in order to get a total of 10 electrons each. So I'm going to add those as my coefficients, 5 there and 2 there. All right, so at this point, the elements that are undergoing oxidation and reduction are balanced. But I've got oxygens that I've got to deal with. And, oops, I've got Na here. I'm just going to add Na plus over here. How many of them do I need? I need 5 because I didn't take it out of that side. So this really could be written as BiO3 minus 1. But since I had the NAs on the reactant side, I better keep the NAs there on the product side. I just forgot to put that in. All right, so now I need to deal with the oxygens. So 3 oxygens on this side, 4 oxygens on this side. So this guy is deficient. So you would think that I would need to add more OHs on this side. But here's the weird thing. You don't see H's anywhere in this equation. And every time I add an oxygen, in order to balance it out, I need to add a water, which means 2 hydrogens. So I'm actually going to add the number of oxygens that I'm deficient by in terms of OH minuses to the extra side. And then I'm going to put waters on the opposite side. Let me raise this up so you can see the whole thing as I do this. All right, so I know it's kind of weird, but that's the way it works out. So take a look. I've got 15 oxygens here. I only have 8 oxygens here. Okay, so I need to account for 7 more oxygens, right? So what I'm going to do is I'm going to add the 7 waters on the side that I have extra oxygens in the same number that I'm deficient. So 7 waters are going over here. Okay, now I know that's totally contrary to what you would normally do. You would think you would have to add waters on this side. But because I also am going to have to balance out H's, and for every O I add, I get 2 H's, this is how I'm going to balance it out. So now I have 7 oxygens plus 15 oxygens is 22 oxygens. I've got only 8 here. Okay, so I'm 14 oxygens short on this side. Also notice I'm 14 hydrogens short on this side. So how can I get 14 of each? If I add 14 OH minuses, now they're balanced out. So I know that kind of blows your mind a little bit, but that's how it works out. So however many oxygens you're short, you're going to add that number of waters to the extra side. And then you're going to balance that out with the number of OH minuses that you need on the what used to be the short oxygen side. It takes a little while to comprehend, but I have faith that you will get it. All right, so now let's take a look at how to balance the same reaction, but I'm going to use half reactions now. Okay, so let me scooch this down a little bit so that we have all of this space ready to work with. All right, so once again, I'm going to write my two half reactions in skeleton form. So I'm actually going to get rid of the sodium for this one, so let's pretend that that's not there, and I'm just going to make that -1 because I just think it'll be easier. All right, so we've got one of the half reactions is Mn2 plus going to MnO4 minus. The other half reaction is BiO3 minus going to Bi3 plus. Okay, so now remember the first thing we wanted to do is balance out the atoms in this case. So I've got Mn and Mn, that works. I've got Bi and Bi, that works. So the next thing I got to do is balance out the oxygens. So I'm going to do the same idea. I have 3 oxygens on the left. I don't have none. There's good English. I have none on the right. So I'm going to add 3 waters to the excess side. And then on the opposite side, I'm going to add 6 OH minuses. So that balances my half reaction out. Okay, so now let's take a look at charge. I've got a total charge of -3 here. I've got a total charge of -1 here. So I need to add 2 electrons. Can you see it? Nope. 2 electrons to this side. I wrote to the left a little too much. Okay, so now charge balances out, atoms balance out, everything's good. I'm going to do the same thing with the manganese half reaction. So I've got 4 oxygens on this side, and I'm short any on this side. So I add 4 waters to the excess side. Then I add 8 hydroxides to the short side. So 8, 8. 8, 4 plus 4 is 8. So everything balances out there. Now let's deal with the electrons. I've got -8, -6, and -1. So I'm going to add 5 more electrons to this side. So now everything balances out, but to add them together, I've got to deal with the electrons being equal in both half reactions. So coefficients are going to be 2 and 5. And then I can go through and do all my math. This one, I'm going to do it separate because I think it's just a little bit easier. To distribute and combine everything can get a little confusing. So I'm just going to say I've got 16 OH minuses, and I've got 2 Mn2 pluses. Now I'm going to go to the bottom. I've got 10 electrons, and I've got 15 waters, and I've got 5 BiO3 minuses. Then on my product side, once again, I've got 2 MnO4 minuses, I've got 8 waters, I've got 10 electrons, 5 Bi plus 3 ions, what in the world, plus 3, and I've got 30 OH minuses. Okay, does that all fit in there? Oh, that's pretty ugly, sorry. This is Bi, That's OH minus. Okay, so now I'm going to start canceling things out. 16 on this side, 30 on this side, so I've got 14 OH minuses total on this side. Okay, because those guys cancel out. That cancels out. Okay, I've got the 10 electrons are going to cancel. In terms of waters, I've got 15 on this side. I have 8 on this side. So 7 waters total on that side. And then everything else can carry down through. So just keeping everything that I need. So there's the overall reaction. And once again, if we compare it to what we did up top with the oxidation number balancing, same thing. 7 waters, 14, oops, not H2Os, OH minuses, my bad. OH minus, 14 OH minuses, so it balances out. So you can see that sometimes the half reaction method works more easily. Sometimes it is a little more cumbersome. Sometimes if you can't get the oxidation number method to work, the half reaction method works okay, and vice versa. So just be comfortable with both of them just to be safe. Okay, so that is how you balance in basic solution. Remember, you add the number of waters to the excess side that you have excess, and then you add double the amount of OH minuses to the short side, and that should balance everything out.